All right. So when I get one of these, like the cross section here on page 28, the first thing I do is look to see what's messed up. And by messed up, we need to know what I mean by just saying messed up. What would these rocks look like if nothing happened to them? They'd all be, what's that called? No, we know that. What's the principle called that would describe what these would look like if nothing was messed up? What? No, guys, think back. Okay, so it looks like we're gonna have to flip back into our notes. What is it called, or what's the principle that describes what these look like if they don't get messed up? Principle of original horizontality. So principle of original horizontality says the layers are nice, and I can't draw perfectly, but it says the layers would be nice and horizontal if nothing messed them up. So we would have some dots. We would have some dashes. Then we'd have some bricks. And then some more polka dots on top. Then some dashes. And then some more bricks. So if nothing messed these up, they would be perfect, beautiful, horizontal layers with nothing messing up those horizontal layers. So before I start, I look at it and I'm like, well, what's messed up? So what are some of the things that are messed up in this picture? There's some erosion. Just start with, there's some squiggly lines. So there is a wavy line here and a wavy line here. So that's saying erosion happened. So that messed up our perfectly flat layers. What's some other things that are messed up in this picture on the top of page 28? Oh, wait, actually, let me go back. So we got erosion. When did this erosion happen? Tell me what it's younger than. So let's go with Y. Younger than 4, older than 5, comes in between them. So keep that in mind when you're doing when you're putting them on here. What about Z? Younger than what? Younger than everything, kind of. We'll get to that in a second. No, why? What's it not younger than? Yeah, the lava thing. It's actually not younger than 3. So I was going to save that, but we can talk about it now. So it's not younger than the lava thing, which is layer 3 here. Hayden, how'd you know it wasn't younger than that? Okay, but how do you know it wasn't younger? Yeah, but then how'd you know this layer came after the erosion? So Hayden said that layer 3 is younger than Z, and he's correct. Because things poking out. If the erosion had gone through, what would have happened to those pokey out parts? Yeah, they would have been washed away. So, right. So we look to see, now we know the erosion's older than layer 3. So we keep that in mind. What's another thing that's messed up? So not perfectly horizontal. There's a fault. So I hear a couple of different answers. We'll start with the fault. A fault is a break. So instead of having nice, perfect layers that match up, we break them. What did that break? So then you got to ask yourself, well, how old's that break? So what did it break? What did the fault break? It only broke 1 and 2. It actually didn't even break layer 4. Layer 4 was piled in on top of that break. And the way I can tell that 4 didn't break is that, see how at the top it's nice and flat? So it didn't even break 4. So 1 and 2 were there, and then the fault broke them. It's the only things it broke. So it's not the youngest, it's just younger than 1 and 2. So we've got erosion and the fault, and what's one more thing that's pretty messed up here? Yeah, the lava thing, layer 3. This is messed up. And now we got to decide, when did that happen? after everything. How do you know that it happened after everything? Two different reasons. One is that it's poked up through all the layers. That's one. The other way, the way I would rather you explain it, is that it's got all the contact metamorphism, the burn marks. This burned every single layer that's here. So you have to be there to get burned. 1 got burned, so 1 is older. 2 got burned, so it's older. 4 got burned, it's older. 5 got burned, it's older. 6 got burned, it's older. And 7 got burned, it's older. Okay, now that you have that, I want you to take a few more minutes and put them in order, keeping in mind that that number 3 is younger than everything. The erosion happened in between 4 and 5. The fault happened after layer 2. So keep that in mind and put these guys in order. Yeah, go ahead and fill out the whole thing. If you want me to come and check yours before you start filling out the rest, so you don't have a whole bunch to erase, I can do that. Let me just make sure I have it written down. I'm checking out a few people who asked before. And when we go over this, I can move it. So you've got 4 open. Yeah, but here's the key. And
I wasn't sure if it was.
I get it. So you can actually leave it. Yeah. So here's how you can tell is that see how it's nice on the top. Whereas like the 2, which is broken, is good on this side of the fault, and then it's down here on that side of the fault. So 4 did not get messed up. Yes.
This is not absolutely bad.
Hey, you really go so long way. So then. Oh, that's why I got it for. Okay. All right. You're good.
We did not include, the fault's not really on here.
So we just went over. I'm gonna take it. You have to make. You can have it at the end of the period. No, because see, I literally just went through this exact thing. And you weren't listening to me. So 1 and 2 are the only broken. Let's try again. So 1 and 2 were there, then it got closed. All right, what do you got?
So this is gonna go, what, at the beginning?
Oh,
Well, I know I got it there.
Oh,
There you go.
Those are all good.
yeah. Right. You're really okay.
Yes, we do distract.
Oh, that's fun. So we'll call this. Guys, if you're wondering what the rock layers are, let's call 1 conglomerate and 5, we'll call that sandstone, but if you switched them around, that part's okay.
Yeah.
Only thing is that 1 and 2 got broken.
Other than
First of all, is it an inch or an inch? The X region, and it's when hot lava. So what is an extrusion? What's it made of? And what's allowed to do? Who's the party you want first?
So what happened?
Okay, who do you want? No. What layer is that open? One and two. And then what happens? Thing happens. Not three, because this whole thing. No, three is not the fault. Axis is right here. This is the fault. This is actually.
What it did. The rest of the
Oh, no, you're good. You're good.
So that's the fault factor.
Okay, that's all we're going with that. Who else wants to check theirs before? Yeah. No, not for fault. What breaks?
Four.
They were being fault. We must have seen them. You do. We are here. All right, you're gonna have to figure it out. Sorry.
Yeah, I want to close.
All right. No, looks like we need a little more time. A question?
So what makes an intrusion? And first of all, is it an intrusion? Yep. And it's missing contact and we're just on the top too, so that's really. All right, and so with that, how does an intrusion or an extrusion? All right, let's do this.
So first of all, like I said, we already go through the steps. What's messed up? We've got the extrusion, we've got a fault, and we've got erosion. Then we already established that the extrusion is one of the last things that happens. So is this erosion. This erosion happened in between 4 and 5. And then we've got the faults. The fault broke what layers? No, the fault did not break all of them. 1 and 2. So the oldest rock layer is the one on the bottom. Number 1 and 2 were there. They were broken by the fault, which was X. What happened after the fault?
Oh, no, I got it.
Layer 4, and then the body, which was layer 8. If you flip-flopped 8 and 4, that's fine. Then what happened on top of 4? That was the erosion, which was Y. Now what happened on top of the erosion? 5 and 6 and 7. Then what happened? Then Z, which was the erosion, and then what do we label? And then the last one was 3. So then the rock types, we already said that this is straight off the reference table most of the time, but because these were hand-drawn, they're messed up, we called rock layer 1 conglomerate. Again, on the test, those will be identical or will have a key. I should have just made a key. 2 is dashes. What kind of rock is dashes? And X is a fault. What kind of rock is 4, which is bricks? Limestone. And number 8 is the body. All right, what is Y? It is labeled erosion, but I need you to know what it really is. It's erosion that's been buried. What is the vocab word for a buried erosional surface? A what? Unconformity. You what? What, Ted? I can't hear you. Hayden, I need that to stop. What did you say, Ted? No, but what did you say? Because if you're confused, I bet other people are too. So this is an unconformity. If you go back to our notes on page, no, well, I didn't write it on that page, but you did on page 22, I believe. An unconformity is a buried erosional surface. It's always represented with a wavy line. It's a gap in the geological record. It's a missing part of the record, meaning a missing layer. So what really happened here is there used to be other rocks on top. There would have been that layer of sand or that layer of conglomerate. Then we would have had the shale. Then we would have had the bricks. And then there could have been any layer here. There could have been whatever this layer is. But erosion came through and erased it. It's like somebody completely took that layer away, but left behind some evidence that they were there. And now we have the sandstone piled on top. So erosion takes the whole layer away and removes it. Whatever was there is gone. All right, layer 5 is polka dot, so that's sandstone. Layer 6 is dashes, which is shale. 7, we got the bricks again, limestone. Now, what do I call Z? Is it an unconformity or is it erosion? Why is it just erosion? Because it's not buried, because it's on top. Good. And then finally, 3, intrusion or extrusion? Extrusion. All right. So then we go through the events like we did yesterday. We're running out of time, so I am going to go kind of fast here. A conglomerate, that would be large sediments deposited in shallow water. So you do need to include the depth of the water for this one. 2 would be clay. Yes, deposited in deep water. What? I had a bunch of water. I had a bunch of you ask me, what do I write for plate darn it. What do I write for a fault? This is when the plates move. So you can write movement of tectonic plates. You could just write plate tectonics is good enough with me. Know that the only thing that can move layers is plate tectonics. All right, limestone is calcite deposited in water. The body, you can write whatever you want. Unconformity is 5 agents of erosion. Move sediment. By the way, where does erosion take place? Where does erosion take place? What do you guys think? Where are the glaciers? Where are the rivers? Where's the wind? Where's the waves? And whatever else I forgot. On top of the earth. So this is on Earth's surface. Sandstone is sand just in water. Shale, we already did that one. Clay deposited in deep water. Limestone, we already did that one. Calcite in water. Erosion, we already did that on the Earth's surface. And finally, what makes an extrusion? Lava cools on Earth's surface. All right, I now need to make sure you understand something else before we move on. So no, we're done with that, but now I want to do what I call a teachable moment using this picture here. So we established, was this an intrusion or an extrusion, this layer 3? Extrusion. What if I altered my drawing and I put some more sandstone on top? Hang on, I don't want anybody to say anything out loud. So I've just added a layer of rocks to the same drawing there. I didn't change anything else. Think to yourself, don't say anything out loud. Is 3 an intrusion or an extrusion now? Think to yourself first and think of a reason why. All right, here's what I want you to do. If you think it is an intrusion, look to that wall. If you think it's an extrusion, look to that wall. So before I put that layer on top, it was a what? An extrusion. So when I just, all I do, it's cooled and hardened, by the way. It's been there for 1,000,000 years. And I put more rocks on top of it. Does it change that layer of rocks? No. So is it an intrusion or an extrusion? What? An extrusion, guys. So for all of you who looked over there, I need you to understand a concept. When lava cools and hardens on the surface, it will forever be an extrusion. It doesn't matter what happens afterwards, it's still an extrusion. This is an extrusion. The one we did the other day, right here. I'm gonna actually put it so you can see both of them. What is the difference between my new drawing and the drawing here that makes the top one an extrusion and the bottom one an intrusion? Because they're both inside, so that's not it. Looking at the pictures, what's the only thing that's different? What'd you say, Jake? On the bottom one, so this one, all the rocks it's touching get burned, meaning they have the whiskers, meaning they have the contact metamorphism. Every single layer has burns on it. This top one does not. And I know this one's harder to see, but you can see it on your own. 1 has whiskers on it. It got burned. 2 got burned. 3 got burned. 4 got burned. Sorry, 3 didn't get burned. 3 is it. So 1, 2, 4, 5, 6, 7 got burned. But what about my new polka dot layer at the top? Did it get burned? No. So it's a brand new layer. So it's still an extrusion. And when they ask you this, first of all, I'm going to ask you this on Thursday. And in case you didn't know, yes, the quiz was moved to Thursday. When I ask you this on Thursday and I say, how do you know This is an extrusion. What will you say? Because the top did not get changed or did not get burned. Or you can say there is no contact metamorphism on the top. My hint, my kind of cutesy way of remembering it, is if the extrusion is bald, then it's an extrusion. And if it's hairy all around, not bald, but hairy, it's an intrusion. You have to know that. So I'm not going to have you ever again do this many. Put them, you won't need to do all of the layers. But that doesn't mean you don't have to understand it. More like what the questions are going to be are like your homework on page 31. And as long as we're at it, if you haven't seen, your homework for tonight is page 32 and page 33, if you want to write that down right now. Page 32 and 33, there's 10 questions. Oh, but I don't want to give you all the answers yet. So instead of making you tell me everything that happens, in fact, that's why I crossed it off at the bottom. Instead of making you make a list of everything that happened, you need to be able to answer questions about everything that happens. You won't need to tell me everything, but it's all still fair game. So first of all, if you couldn't tell that that was an A, that blob is an A, it asks A is younger than what? Hey, Brad, how do we tell which layer is younger? What do we, like, where do we look for younger layers? Yes, the closer to the top, the younger it is. So here's A. It's what? Yeah, you had the right answer, so I knew that's what you meant. A is only younger than layer B. And again, because it's higher up, it's closer to the top. The next one, I actually want everybody to double check their answer because in third period, legit, every single person got it wrong. Rock layer Z represents the exact same layer as what? Everybody don't say anything out loud, double check your answer. Who's willing to give this one a shot? Luke? It is E. Did anybody think it was H? Lots of people did. Make Jake feel better. Who else thought H? There's got to be more of you. Yeah, okay. Almost everybody's raising their hand. So guys, when they say which layer is the same, it doesn't mean the same rock kind. So yes, H and Z are both shale. But they're not the same age. What? They do line up, so that stinks. But double check their order. What's a little bit younger than Z? That would be the bricks. What's a little bit older? That would be conglomerate. If I look at H, on top is not bricks and below is not bubbles. Oh yeah, look at that. And there is the contact metamorphism there on Z, which matches up with the contact metamorphism on E. That is the kind of stuff they do just to mess with you. You guys understood the concept, but you didn't double check. So you know how my number one rule is read all the words? Well, it's also look at all the pictures. All right, so that's E. Which rock layer are fossils least likely? So least likely means not found. What kind of rocks are fossils found in? No, what kind? Ted, knock it off. Fossils, guys, this was from chapter 3. Fossils are only found in sedimentary rocks. See how they're mixing chapter 3 with chapter 6? They love it. So they're only found in sedimentary rocks. So then they're not going to be found in igneous rocks. So layer C and B. Rock layer C is at an O. Perfect. Review from earlier. Is C, and no one say anything out loud. Is C an intrusion or an extrusion? Double check now that we reviewed it. Intrusion or extrusion for C? Don't say anything out loud yet. Let everybody think. C, intrusion or extrusion? Oh, stop saying it out loud. Cynthia, what is it? It's an extrusion. Connor, how did she know it was an extrusion? No, that's not it. There was something that we just talked about over and over again with the last pictures. Not because it's on top. Because it's bald. If it's bald, it's an extrusion, but I do have to warn you, you can't say that on the Regents. You got to tell me what you mean by bald. You mean there's no contact metamorphism. That means there was nothing there to get burned when it was born. So this is an extrusion. Since it's an extrusion, will it have big or small crystals? Small. Do you remember why? Okay. Because it cools fast. That was chapter 3 as well. Extrusive rocks, which are volcanic, meaning they cool on the surface, have small crystals. All right, the next one, it just named the rock. So G is polka dots, that's sandstone. And A is bricks, that's limestone, right off the reference table. Now, the last 3 are throwback to chapter 3 as well. They ask you, what metamorphic rock would be found in layer E at the site of the contact metamorphism? So here's E. E is shale. I know that because it's dashes and I check my reference table. It's asking where this hot lava touched it and changed the rock. What metamorphic rock does it turn into? Where do you look? We look not 6, but page 7. So it said metamorphic rock. So you look in the metamorphic rock chart. And if you see, right, if you go down the comments section, shale turns into slate. If there's any time when you're like, I don't freaking know, why would I know that? The answer is somewhere in your reference table and use the hints they give you. By the way, layer A, which is limestone, limestone turns into marble. And D, which is conglomerate, turns into metaconglomerate. And yes, guys, don't forget your homework, which is 20 or 32 and 33.
Recommending